Okay, let's get started. Hola a todos los que se han conectado a nuestra sesión de mensual. Quiero presentar a dos increíbles desarrolladoras que esta vez nos están acompañando. Eh, Esta sesión se llama Open Cloud Native Java. Eh, Este es nuestro evento mensual. Como les decía, contamos con la participación de dos excelentes expositoras con mucha experiencia en el área de Java. Empecemos con Grace. Y Grace es una Java Champion, es desarrolladora en IBM y trabaja en Open Liberty. Y también contamos con la presencia de Emily. Ella también es desarrolladora y champion de Java y trabaja en Liberty Cloud, es defensora principal, miembro senior del personal técnico de STSM en IBM, con sede en Reino Unido. Ambas están allá, o sea que para ellas es la tarde ya, así que empecemos de una vez, vamos a cambiar a inglés. Víctor, te paso la batuta.
Okay, gracias, Majo. Okay, good morning, everyone, and welcome to our live streaming events today. I'm very excited to introduce you to two amazing guests who are expert in the field of the Java development. So joining us today are Emily Jiang and Grace Jansen. I hope I pronounced it well.
Yeah.
Hi, ladies. Okay. Well, as Majo said, Emily and Grace are both lead developers at IBM, and they have years of experience in cloud technologies and enterprise applications. And they are here not to share to share their knowledge and insights with us in this exciting topic that is called Open Cloud Native Java at Light Speed with Open Liberty. It's very exciting for me because I I don't know a lot of this field, but I'm proud for you girls to be here to talk about this topic.
Thanks so much for having us.
Yeah, great. Okay, thanks for the great introduction. Let's get started. We have a lot to talk about. The first thing is, I think is in the past, probably you already have some sessions on the JakartaEE. So basically, I want to just trying to say in the when you do Java Cloud Native application, there's two programming model you must learn. One is JakartaEE, the other is a MicroProfile. So you need to use this open standard so that to make sure your cloud native applications and portable among a lot of different runtimes. Let me give you a quick, I'm not going to talk a lot about JakartaEE and MicroProfile. However, later on we are going to have, I'm going to do a demo so you will see how they help out with your cloud native applications. So it's just to do a level set on the JakartaEE. So JakartaEE, if you have not heard of JakartaEE, basically it's the successor of Java EE. So it's in September 2017, Java EE rehomed to Eclipse Foundation and rebranded to be called JakartaEE. So this is a bigger priority. The one main thing you need to remember is open standard. The other one is kind of target for multi-cloud and modern applications. Plus, this is kind of the we basically invite all of you come to help us to the work on more improvement on the JakartaEE. So it's the kind of the now we are target for a faster pace of innovation, and also we do more specification update and new specifications. Also want to target more like a native integration with Kubernetes. So this is JakartaEE effort is backed for the Java industry leaders such as IBM, both Grace and I work for, Oracle, Fujitsu, PR, Tommy Tribe, and there's other companies like Microsoft, Red Hat, and a lot of Chinese companies also involved. Plus, there's some JAGs, like Garden State JAG, iJAG, and Istanbul JAG, and etc. So it is, and also London Java community. So it's basically a very mixed, industry leaders and also contribute towards this effort. And since the move from Java from Oracle to Eclipse Foundation, and basically it has the Jakarta has undergone a few releases. The first one is JakartaEE 8. So this is not much changing. The only change is basically open source TCK, and also the Maven coordinator change from JavaX to Jakarta, and then followed on by Java EE 9 and 9.1. This is pretty much JavaX to Jakarta namespace change. So the package, if currently you are using JavaX on your import, and to move forward, you must migrate to be Jakarta. So it's basically adopt the new release of the JakartaEE. So it's only last year, like September 22nd, we did a major release, which is JakartaEE 10. JakartaEE 10 has 3 flavors, 3 different releases. The platform, you can see, it contains 30 specifications. Majority of them in blue, basically has some major or minor update. And then there's another flavor, which is subset or platform release called web profile. So this is for web applications. There's about 22 specifications. And then the other concept release is called core profile. This is a new profile. It's in a new profile in the JakartaEE 10. So it has 7 specifications. So this one is directly created for MicroProfile. So which is, I'm going to talk a little bit about MicroProfile. MicroProfile was created in 2016, and in the trying to target the microservice for Java applications. And then it's created by IBM and together with others. And then in 2017, it moved under Eclipse Foundation. The latest version of the MicroProfile, so basically is the packaged JakartaEE 10 core profile in MicroProfile 6. And plus, these 8 MicroProfile specifications. The new specifications, the telemetry, and there's a few updated specifications, Open API, REST client, config, fault tolerance, and also is a metrics as some major change, and GWT authentication has manner change, and also the health. And then the other release is called a standalone release, such as the open tracing, reactive messaging, reactive stream operators, LRA for doing transactions, GraphQL, and context propagation. So prior to MicroProfile 6 is like a MicroProfile 5, and earlier you have MicroProfile open tracing in the release. However, if you follow the kind of observability, kind of all the movement, under CNCF, there's a new initiative and also a new project called Open Telemetry. So basically, it's a merge of open tracing and open sensors. So with that, open tracing is no longer in active development. It's went to the maintenance mode. So which is why MicroProfile adopt open telemetry tracing and then move the open tracing to be like a standalone. So with this, as you can see here, the JakartaEE 10 core profile has this kind of the 7 specs, and then plus these 8 MicroProfile specs. So you will have a 15 specification APIs available to you once you use MicroProfile 6. So this is a basic chart about the releases on MicroProfile since 2016. Like in 2016, I want to highlight basically the package, the 3 Java EE spec, JAX-RS, CDI, and JSON-P. And then is, in December last year, we released MicroProfile 6. As you can see, it's grew the JakartaEE kind of the portion. Now it's a package JakartaEE 10 core profile together with this 8 microprofile specification. So it's moved really rapidly. So it's offered very rich cloud native APIs to your application. And also MicroProfile is backed by the industry leaders, including IBM, Tommy Tribe, Red Hat, Microsoft, Oracle, and Piara, Fujitsu, and etc. IJAG, AJAG, Garden State JAG, and Pramton. So it's quite a few members. And plus, in MicroProfile, it has many kind of implementations. In this talk, we're going to focus on open liberty. So it's basically open liberty has been used as a compatible implementation to release MicroProfile 4.1, 5.0, and 6.0 since the working group was created then. So as you can see from the compatible implementation, is the open liberty is up there on the top. And also there's more and more runtime are trying to implement a MicroProfile. Basically, for the runtime to be able to appear on this page, compatible implementations, so they have to pass all the TCKs. So all the MicroProfile TCKs they prove they passed all the TCKs. So which means the application written with using MicroProfile APIs, so they can move around these compatible implementations without any behavior change and etc. So they are portable among these compatible implementations. So this is one thing I want to stress is open liberty is fully embrace this open standard. So basically we open liberty trying to implement this JakartaEE and MicroProfile releases as soon as possible. As you can see here, lately is in 2303 was released in the beginning of April. Is the first runtime implemented. Also first production ready runtime implemented both JakartaEE 10 and MicroProfile 6, which I'm going to demo later. But first, I think is open liberty is being talked about for some time. I think is let me pass over to Grace to give you some highlight of how awesome open liberty is. So Grace.
We've had an understanding, as Emily's run through, of what JakartaEE is and what MicroProfile is and why they're helpful in terms of portability, having that open standard. How do we use them? Well, we need an implementation. And as Emily pointed out, there are multiple different implementations you can choose from. Today, we're focusing on open liberty. So what is open liberty? Next slide, please. So open liberty is really this evolution from a product that you might have heard of called WebSphere. But it was really designed back in 2012 to be able to be really lightweight, designed for the cloud, composable, much simpler, much smaller, and modular in nature to be able to sort of really optimize that memory footprint, performance, and allow rapid innovation of different features and innovations within the product. So it really is designed for the cloud and designed to be easy to use for developers. So let's take a closer look at that. So in order to do that, we have to understand that, different applications are designed in different ways. You might have a monolithic application that you're trying to modernize. You might be starting greenfield and going straight for macroservices or microservices or even functions. But the nice thing about Liberty is that we're able to essentially provide the right runtime across this continuum of different architecture styles, so applicable to pretty much most applications, regardless of the style in which you've designed your application, because we have those we've got the entire we support the entire APIs of Java, of MicroProfile, of JakartaEE. So we're able to sort of span this continuum as compared to sort of other competitors who perhaps focus on one type of architecture over others. Next slide, please. And as I mentioned, it is modular. So the whole point of this is we are really trying to minimize the size of our applications so that we can run efficiently within the cloud. And in order to do this, really what we want is just to have just enough of an application server. So just the features that we need to make use of, and not some huge bulky application server with half of the features not even useful to our application. And that's the nice thing that you can do with Liberty, is to be able to control which features you load into each server instance, depending on your specific application. So really making it tailored to you and making it optimized for those cloud costs. Next slide, please. Thank you. And that goes into sort of building as well. So being able to sort of streamline the process of building by providing really first-class support for the various different build tools you might be using, some of the most common like Maven or Gradle, so having plugins for those, and releasing all of our sort of runtime and features to the Maven Central, which allows you to be able to sort of mirror those into internal repositories for performance or governance reasons, to be able to sort of, basically what this allows you to do is sort of separate out the fact that you don't need to install Liberty and the individual features that you need. The build will then just pull all of those down for you as and when they're needed. So pulling on this whole modular system, but automating that for you when it actually comes to building the applications, especially in a container manner, which is essentially what many of us are using when it comes to developing and deploying to the cloud. So really it's about a really lightweight application server that allows you to pick the features that you need to minimize the size of the application server and allow you to deploy it in a cloud native manner. So this is sort of the main benefits and what OpenLiberty offers as a cloud native runtime. So let's deep dive into the development and ops side of things and how Liberty offers different features and tools and technologies to be able to make this inner dev loop much more efficient, much easier for developers, and much sort of more effective. So what we've done here is we've planned out various different phases in which we usually progress through when it comes to developing applications that are designed for the cloud and then deploying them into those cloud environments. So we've split it out into different sections. So the first thing is obviously our planning, our design phases. Then we're going to go into some coding, some editing. At some point, we're going to want to build our application. And of course, we're all excellent developers, so we're going to be testing our applications as well to make sure that we have confidence that they're working as expected. After that, we're probably going to have some kind of release, and that depends obviously how frequently, depends on your particular application, but also how your organization is organized as well. And then at some point, we're going to be deploying it, running it, and obviously we want to be monitoring it live within that cloud environment as well. So let's deep dive into each of these sections. So the first thing I want to touch on is some of the tools that are available within Liberty. And the nice thing here is that, again, we've really designed this with developers in mind. And we have tons of developer tools that can help you when it comes to this code stage. So this actual, okay, what do I need to do to be able to actually produce the code to write my application? The nice thing is if you're starting afresh, what you can use is our starter project, which you can use at start.openliberty.io. What this allows you to do is just select from various different drop-down menus for things like your Java version, what MicroProfile version you'd like to use, what build tool you'd like to use, Maven or Gradle. So it's a really simple form, takes about 5 minutes. And then what it will produce is a zip file. And in that, it contains a skeleton framework for an application. So you can get up and running using OpenLiberty with that skeleton framework within 10 minutes. So super easy to get started, really useful, especially if you're new to this framework or just new to producing Java applications. We've also got things like dev mode, which I'll go into in a minute. Obviously, I've mentioned things like the Maven and Gradle plugins. You can also utilize other build tools as well, like, for example, build packs. So if you're interested in things like Paquito build packs, you're able to utilize those instead of Docker files to be able to get your application up and running just from the source code. So that's a really interesting one, and we do have some documentation on that if you're interested. Or other things like source to image if you're using OpenShift, and obviously the original Docker files as well. We've also got some testing tools as well, which we'll go into in that testing form, and some debug sort of helpful features and tools as well. So let's take a closer look at dev mode, which I mentioned. Dev mode is a really awesome feature that we have within OpenLiberty that allows us to sort of on the fly really sort of know when we've had file changes. So it's essentially always watching our application for file changes or class changes, and it's able to rebuild and redeploy those particular classes that we've changed as and when we save them, which makes this a very dynamic and agile process, being able to see those changes in real time into our deployed application without the need to completely tear down our entire application and rebuild it again. So it's really rapid, really iterative, and allows that more agile style of development, which is what we're aiming for within not just cloud development, but more modern application development. So no rebuild is necessary, no redeploy, no install, no restart, literally just you coding. And as you save the file, as you can see in my demo here, as we're saving this file, you can see this terminal is updating and it's already picking up those changes to be able to sort of bring those up into my deployed application automatically for me. And the nice thing is you can also use dev mode in containers. Obviously, we're building for the cloud here, so we want to be building in containers. So you can also use something called dev C, which is dev mode for containers. So that's another mode you can use. Really, again, designed for that iterative development cycle that we're going through as developers. So a fantastic feature for you to be able to utilize in OpenLiberty. Okay, so next slide, please. Thank you very much. So as Emily mentioned, as well as sort of the actual tool itself in terms of the runtime, OpenLiberty actually integrates with and is an implementation of many useful, really useful cloud native APIs. That includes some from in fact, all of the ones from MicroProfile and JakartaEE, but it also includes other open source APIs as well to really enable you to modernize your existing Java applications and to be able to port them to the cloud in a very effective manner. So it includes things like testing technologies, building technologies, lots of different APIs available. We actually have guides on all of these APIs available on our website that you can check out. So if you're interested in any of the APIs that Emily mentioned from MicroProfile or from JakartaEE, and you want to give them a go in an easy way, then our guides only take 15 to 20 minutes, and they go through each API individually, explaining how you use it, why you'd want to use it, and then giving you an opportunity to try it out yourself. So I definitely recommend giving those a go. The nice thing is that we've got them available on our browser-based IDE environment. So you don't even need to have the prerequisites on your local machine. So if you've got a restricted machine for work, no problem at all. All you need is a browser and you'll be able to get started, play around with it in about 15 to 20 minutes in that browser itself. So a fantastic tool, and it's available on openliberty.io/guides. We'll have a link at the end for you, but you can head there or just search in Google OpenLiberty guides and you should be able to find them there. So this really allows you to be able to have that sort of lack of vendor lock-in and to have that portability and flexibility that Emily talked about. Okay, so testing. Obviously, we want to be able to ensure our applications are working as expected, that we have that quality testing. And so this is where utilizing a mixture of unit tests and integration tests and end-to-end tests can really help to ensure that our application is working in every aspect, not just in those individual unit tests. So obviously we have the usual suspects that we can work with like JUnit and Quillian, but we also have some really exciting newer frameworks that we can make use of, like for example, test containers. We're developing applications that are going to be deployed into containers in the cloud. So it makes sense for us to try and mimic that environment on our own local machines to ensure that our integration tests are as close as possible, as similar as possible to those production environments, so we can minimize the risk of new errors creeping in as we move from development to staging to production. And so we can use things like test containers to replicate that production environment in our local machine by providing containers in which to test in. So any backing services that we have can be connected through different containers to be able to mimic that production environment. So we can utilize test containers. We can also do things like consumer contract testing with things like the Pact framework as well. So loads of different frameworks that we can integrate with when it comes to OpenLiberty. And again, we've got guides on all of these if you want to check them out. Next slide, please. Okay, so now that we've tested, what about deployment? So when it comes to deployment, we have lots of different sort of solutions in place to be able to ensure this is much easier for you when it comes to deploying with OpenLiberty. Kubernetes is obviously a wonderful container management solution, and it's supported by all the leading clouds, giving us that sort of common environment that we can trust. Kubernetes configuration is very flexible and extensible, but it's not domain specific. It doesn't know anything about what runs inside the container. So it can't really optimize the configuration for specific workloads. This is where things like Kubernetes operators come in and enable us to achieve that. Operators are essentially extensions to Kubernetes that help to simplify specific tasks, like, for example, managing Liberty deployments. They define their own configuration in the form of a custom resource definition, and because this configuration is read and understood by the operator, it can be very domain specific and much more concise and simpler to use. So we actually have a Liberty operator, which you can kind of see some of the code for here on the right-hand side. And what that allows us to do is really reduce that configuration by up to 80%. So really optimizing our code there, automate common tasks, and insulate from Kubernetes complexity. So really trying to make this as simple as possible for developers to get up and running, deploying their applications as efficiently as possible to the cloud. So this can be a fantastic tool to be able to utilize no matter where you're deploying your application, no matter which cloud platform you're using. But we also have some specific tools for each cloud platform as well. Next slide, please. So when it comes to actual cloud deployments, often what people ask is, is Liberty supported in these different cloud environments? And the answer is yes, absolutely. Liberty is designed to work on a variety of different platforms, whether that's virtual machine or managed Kubernetes or managed OpenShift environments. You can use Open Liberty in pretty much any cloud environment. So we've got here things like Azure, AWS, IBM Cloud, Google Cloud. Again, this is drawing on those sort of behaviors that Emily was mentioning earlier: portability, flexibility. So if you want to change the cloud provider you're with, you wouldn't have to change your application because it's running on a cloud native runtime that can be run on any of these cloud platforms. So it really enables that sort of confidence and trust that you're not going to have to rewrite your entire application to give you that portability and flexibility. And we have a lot of support on all of these platforms. We've got sort of our Liberty is often offered in the actual marketplace and partner solution options that allow you to be able to simplify deployment into them as well. So you can see some examples on the right-hand side here for things like AWS, Azure, on OpenShift directly as well. And we've got some links to some documentation there for things like Microsoft Azure, which really shows how we can make that a lot easier because we're working with these partner organizations to make that deployment a lot simpler and sort of just with a few clicks of a button, really. So again, super easy for this deployment stage, either using an operator or using these specific cloud deployment techniques. Okay, so now that we've got it deployed, we really want to be able to know how our application is behaving. And for that, we need to use monitoring. Now, Emily already mentioned this with the whole MicroProfile tracing and the fact that that was moved into a separate project, but we now have telemetry within MicroProfile 6. And so this sort of links in here into this observability and the fact that really what we want to be achieving is to be able to know how our application is behaving in real time in the real world. And for that, we need a variety of different metrics and information to be collected. It can range from logging, for example, to tracing that we mentioned, metrics, and health. And by combining Open Liberty with the MicroProfile APIs, we can enable this effectively. All of these different types of observability, all 4 categories can be enabled. We have logging sort of inbuilt into Liberty as a tool, and then we can utilize MicroProfile metrics, MicroProfile health, and MicroProfile telemetry to be able to enable metrics, health, and tracing. And this really allows us to understand in many different ways how our application is behaving, the load on our application, whether our microservices are healthy or not, what strain they're under, how their performance is, and how operations, for example, or requests are progressing through the various different microservices that our application consists of, to understand if there's maybe bottlenecks or failure points within our applications so that we can act on those as soon as possible in case of that potential failure. Thank you, Emily. So we've kind of gone through all of the steps within this circle. Excuse me. And we've looked at how Open Liberty can offer various different tools for each to be able to enable that more efficient and effective development cycle through not just development, but also operations as well when we've deployed it into the cloud. But how can we enable sort of this sort of seamless concurrency and elimination of technical debt when it comes to continuing this circle? Because we're in agile development. We don't just do this once and release our product and that's it. We are continuously going through this circle, continuously iterating over this cycle. And so it's important that we can enable to continue innovating and continue to enable new features and new sort of enablements for our clients when it comes to innovating on our applications. So for this, Liberty has some fantastic abilities One particular one, which I think really it offers that lots of its competitors don't necessarily offer, is this zero migration. This ability to stay current without having to make any configuration or runtime behavior changes. So being able to move up versions without having to automatically change everything within your code or automatically move up to the latest version of every single API, for example. So zero migration is a big thing that we really emphasize within our Liberty development to ensure that you can keep staying current. You can make sure you have those security vulnerabilities eliminated so that you're moving up to the latest versions without having sort of the need to be able to put a lot of energy and effort into completely rewriting your applications. We also offer obviously continuous delivery. So we release a full release, so GA every 4 weeks, and we have quarterly LTS releases as well. So really, we're trying to stay relevant and offer you the latest innovations as soon as we can as a runtime for you to be able to pass on into your application for your clients to make use of. So really, we are CI/CD optimized and sort of offering that as a runtime for the applications as well. Next slide, please. Perfect. So we've kind of covered everything that there is to cover really in end-to-end cloud-native DevOps delivery experience as a developer or a DevOps team within your application when using OpenLiberty. But there's also the question of, okay, OpenLiberty seems to have lots of tools. It integrates with lots of APIs, especially open source. But what about performance when it comes to deploying on the cloud? How do I know it's going to perform well? So let's take a look at how we've optimized OpenLiberty, not just for the developer experience, but also for performing well in the cloud. Next slide, please. Oh, and next one, thanks. So in order to help reduce costs and also achieve sustainability targets, we've worked hard to be able to offer sort of great performance in terms of throughput, but also lower memory, which means you'll need less hardware for the same workloads. Less hardware means lower infrastructure and license costs, and it also means lower environmental impact. So you can see from this graph here on the right-hand side just how small that is in terms of our memory footprint and our throughput offered when using Liberty compared to some of the other products that are out there. So for example, I think we've got here like Quarkus, Spring Boot, Tommy E, JBoss. So you can see there's some massive performance improvements there just from moving to MicroProfile, not changing the application itself. Next slide, please. As well as the actual performance of the runtime, we've also made some recent innovations which are really exciting when it comes to cloud-native development. One of those is instant on. So if anyone's come across the term CRIU is another way of pronouncing it, CRIU. This is an open source technology that we've utilized within Liberty to be able to offer really fast startup times. You know, you're getting close to sort of the serverless startup times here to be able to really make it ideal for more serverless style applications and make it up to 18 times faster than just a standard deployment of sort of generic OpenLiberty without instant on. What it allows you to do is it takes a checkpoint or a snapshot of a running application server, and it allows you to be able to restart from that instead of restarting everything all over again when you want to restart your application. So you can see here at the bottom, this diagram shows that we get to the build phase, we take that checkpoint and we can use that checkpoint to restore for our various different environments, making it much faster to be able to do that and more similar to sort of a serverless environment. You can see on the right-hand side what we allow that with. So we've got Semru Instant on here, the Semru JVM, and the Graal native. So you can see here the fact that the main benefit of this is really you're allowing these fast startup times without compromising your application. So it still supports that full Java language, and it also allows you to be able to utilize elements of the JVM for optimizations like JIT servers, which you can't achieve if you're just utilizing native images like Graal. So there's some real, not just performance benefits of using this, but the fact that you don't have to compromise your application and you can still use that full Java language API, and also the optimizations offered by the JVM. Speaking of the JVM, we've also done cloud optimizations, next slide please, that involve the JIT compiler. So being able to have a separate JIT compiler, so separating out the JIT compiler from the JVM to offer JIT as a service, to be able to really optimize that to allow you to have sort of dramatically reducing peak memory usage and simple Kubernetes enablement through the Liberty operator. So this is a fantastic way of being able to optimize your application by really essentially sort of moving that out into its own microservice outside of the JVM to sort of maximize our impact with that. So that's another optimization we've allowed. So really you can see through things like JIT as a server, instant on, and our performance benefits that utilizing OpenLiberty can help to be able to enable efficient deployment onto the cloud when it comes to performance, things like higher throughput, lower memory, and being able to start up your application much faster, much more sort of in an agile manner. So those are some of the optimizations in terms of performance. When it comes to modernization, next slide, please. Liberty is also a fantastic choice for this because of that breadth of being able to use Liberty all throughout the different architecture styles, no matter how or where you are in your modernization journey, because we can obviously do things like we have support for not just containers, but also for VMs and Kubernetes. We've got first-class support for monoliths to macroservices to microservices, all the way to that more function style with things like instant on. And we also have full support for Java EE, but also JakartaEE and MicroProfile and many other open source specifications and technologies. So being able to utilize not just OpenLiberty, but also the underlying tools that support that modernization journey, like things like Transformation Advisor, so showing you how you can transform from more traditional application servers like WebSphere to something like a cloud-native runtime like Liberty, and then how you could potentially move to more microservice-based application architecture using tools like Mono to Micro. So some fantastic supporting tools that you can also make use of when it comes to utilizing Liberty for that modernization journey as well. So hopefully what I've shown you throughout that quick 20 minutes is really how you can utilize the tooling, the technologies, the open source support, and the performance in utilizing Liberty to effectively enable your cloud native applications to run on the cloud as effectively as possible, really to thrive in that environment rather than just survive in it. So I'm going to pass back over to Emily now to really demo some of the capabilities that I've run through here and showcase how easy it is to get started with them. So over to you, Emily. Emily, are you on mute?
Am I still on mute?
Yeah. No, you're off mute now. Yeah, great.
Okay. I think I was muted. Anyway, thank you, Grace. So it's basically we have talked about JakartaEE, MicroProfile, and OpenLiberty, and how awesome OpenLiberty is. It's a time to demonstrate. So it's in this example here, basically I created two microservices. So it's service A and service B. So it's, service A is directly calling in service B. Let's have a quick look. So so basically this is the cloud native microservices. So I'm using MicroProfile 6. So it's trying to demonstrate all the the awesomeness of MicroProfile and their OpenLiberty. So basically, is in your plugin, you just directly say OpenLiberty tools, Maven plugin, and etc. You will get a Liberty. And let me just start these two microservices in dev mode. So it's also if you are using different plugin, different ITE I'm using VS Code. Also, you could use IntelliJ or Eclipse. There's a tool called the Liberty Dashboard you can install. And then let me just start both service A and service B. This service A has started, and let me start service B. So I can directly just say start. And then it basically is will install the feature, and then it will monitor any code change you have. So let's it's already started. So it's basically we can go to the browser here. I know service A is directly on the 9080. See, so 9080. So basically it's I show you here is the rest. Basically, this one is directly service A directly calling into service B. So how did I wire these two things together? So it's basically, let's have a quick look at service B. So it's service B actually is just have two endpoints. This is even REST. So the service B has two REST. Like one is called like a client service controller. So it has one operation like do something. It's a get operation. The other like endpoint is the protected get GWT based value. This let's have a look how to call the do something from service A. So it's that's use the MicroProfile REST client. So all I need to do is I create interface called you can give it any name. The important base is get operation and is do something and has one parameter. It's basically pass param. All you need to do is annotate it with register REST client directly from MicroProfile REST client. And then in your services, just as resources, you can directly inject this REST client, so basically service, and then you call it. You can just to call service.do something. The implementation automatically create an instance of this service and will call the like method do something. And you might be wondering, how do I know service A? How can service A know where service B is? And how can, like when I call do something, it automatically goes to service B to call it? So the beauty is to use the MicroProfile config. So in MicroProfile config, the integration with MicroProfile REST. So basically, you use a fully qualified class name, which is service in here. So this class, com.example.gates, and then is /mprest/URL. You just put service B's endpoint there. And then when you call do something, it automatically go to that endpoint to call do something. And then now, if I'm trying to say I want to add something else, I want to say hello, and then I will say, for example, I will say conf, and then I will just return that. Obviously, I need to define this conf. However, I don't really want to hard code conf. And then I can use the MicroProfile config to inject it. So if I say here name, if I say conference, and then I do a string conf, and then I can inject it. And the other beauty of the Liberty is there's also we have the plugin, we have the IDE support, which is LSP for MP. So basically, it's automatically give a warning to say, hi, by the way, you have not defined this conference. If I save it and immediately, if I go to my terminal, for A, I got an error message already to say, okay, this is not defined anywhere. So I can easily basically define this conference. If I type here, if I say conference, if I do I will just say, actually, this is Jack conference. I save that, and then it's happy again. So it's happy. Let's go back to see what is like. So you can see here directly. So hello, Jack, right? And then here is actually I need to add a space. So I just start saying, okay, yeah, I'm not happy with the format. I can easily basically going back here to say, actually, by the way, you need a space here. I just add a space, and it will be happy again. Let's go back so you can see it's picked up changes straight away. Let's go back here. Yeah, you can see it changed. By the way, if I just directly trying to call it over again, and like sometimes it's not quite working, basically it's giving me the cached value. Sometimes it's really slow. Considering you say, how can I fix? I noticed this problem. So I know it's something really not quite behaving in a microservice B there. And you say, how can I fix the problem? You might say, okay, you should just fix the backend. And sometimes you can't really access the backend. You use some other third-party services. I know here, like I deliberately add some space and also through some exception. And then considering you only own service A, how can I fix service A to give me a really satisfied like a response time? It's sometimes really, really slow. So the kind of the best tool for this is MicroProfile fault tolerance. So MicroProfile fault tolerance provide a way for you to create a resilient microservices. So I know it's sometimes slow. I can just say, actually, I'm not happy if it take you a long time to give me a response back. Actually, I said maximum time I can wait is 100 milliseconds. So it's I can just say timeout 100 milliseconds. If you use the timeout, the best practice is always make it synchronized. So it's again, it's synchronized if you know Java 8, and that would be pretty much like is a kind of parallel programming. So it's use a different thread to like calling this operation, calling this like a service. And the return type, you can return like a completion state. Obviously here, you need to return completion state. You can just do completable future dot completed stage here. Let me quickly to there. If I just do that, and then if I save that, let's go back to the URL again. So you can see here, like you can just monitor here is 7, here is 8, here, and sometimes not quite working. So that's because this one is still flaky, but at least you have not got a long wait. It keep on spinning. Let's still trying to fix it. So it's sometimes it's not working. So I know it's like sometimes it worked. So obvious, the fix will be okay. Let's do retry. Don't want to configure it. So is I can just use a MicroProfile like the other capability. If something not working, let me retry and let me save it, and then let's go back, and now. So it should work all the time. Yeah, you can see 14 directly jump to 16. That's because you get a timeout, and then it did another retry and give you response straight away. So this is kind of the quick demonstration how to create a resilient microservices. If you think you are going to deploy this to the cloud, the other best practice is so basically is you provide a fallback. So the fallback, for example, I can just say that if something goes wrong, and please call this operation. So basically, please call my fallback. So obviously, I need to create the fallback method. So I can, the fallback method will be used exactly same signature as the calling method. So my fallback. And then you can just say hello. Obviously, you don't want to call exactly same operation, you can just say, this is my fallback. Yeah, so this is kind of like a quick demonstration how to create the resilient microservices. The other thing is with all the MicroProfile 6 and your application automatically documented. So if if you do Open API, you got all the kind of documentation. If you know Swagger, this pretty much you know them. In Open Liberty, we also give you UI, so you can directly call this one. We keep on invoke this operation. If you just say hello, you provide this method, this parameter, you execute. And then you can see here is basically it's 200, so that means successful. You go successful, so you get some a rough this is documentation. If you want add some particular basically the response what 200 means, what 400 means, and then you can use the Open API annotations. So it's basically in here, you can do the response, and then you can do the API responses, operation, and which response for what, quickly. So 404 means what, and 200 means what. And you can even configure the content in a different format, in a text plain. Let me save that. Let me go back to the browser again. So as you can see here, if I try it out again, if I do hello, execute, and you can see previously asked me download. Now no longer, is because I changed the format to be a text. So you can see this straight away. So this is the documentation side. Plus that, actually, you get all the metrics data. If I give you the endpoint metrics, so you can get all the metrics, even including the photons, the timeout, and the retries, and etc. And these metrics, endpoint list all the metrics. If you want a particular scope, there's an application scope. Just list all the application metrics. If it's a base scope, you just list this base scope. So this is the kind of quick metrics. The other thing is also in MicroProfile Health, Grace mentioned, actually is especially in the Kubernetes environment, you will need to tell Kubernetes when your microservice is ready to serve a request, when the kind of the started, whether it's still alive. So you use MicroProfile Health directly to do that communication. So here is the annotation readiness for the readiness for Kubernetes readiness check, and similarly is liveness is for liveness check, and startup for startup check. So it's in MicroProfile is automatically give you some endpoint. So it basically is /health and also /live. So give you that this is liveness status, and similarly is ready, and also there's started. The other thing I want to quickly go through is not only for the simple applications, even for the secured endpoint. As I mentioned earlier, it's basically is the service B has the other secured endpoint. So basically, you can directly call the secured endpoint. So it's in the service B there. Says there's the endpoint. So basically, it's saying only protected is allowed to access this endpoint. And in service A, how could you invoke this service B? So it's actually how data works is basically in the service A, in this one, I use like JAX as client. So it's basically you create this client, and then it's when you're calling that client, you just pass on the token JOT token, so authorization barrier token, and then it's automatically, so this like display the response. So for that token, so it's a MicroProfile JWT token. It uses JWT, but it's added two claims like UPN and also groups. As you can see here, passing the group is protected. So that's why when the backend received that, it said, oh, okay, protected. Yes, you can access me. If, for example, the microservice B here, if I change to be like a super, for example, if I save that, now if I go back to the URL again, and if I click it, so it's just denied my access. If I directly go back, and it will work again. The other beauty is I can even see the JSON web token. If I say token, and here I can do, for example, token, and then token.get raw token. If I save that, you can see here, if I click that again, so I can even get the token. So the token, looks like it's kind of very kind of gibberish kind of the things. However, if you directly put into the JWT.io, so it's you can see actually because all this is encoded. So you can see here is a token, and you can see all the kind of the groups UPN is all in clear text. So you can see that's exactly the token you passed through. So that's kind of the quick way to walk through the MicroProfile, specifications, and enable you to do the cloud native building. The other quick thing I want to just say is briefly demonstrate the open tracing, the telemetry. So it's in order to do the telemetry, so basically you need enable. So you need to tell them, you need to just tell you want to get this tracing enabled, to just configure it to say here disable equals false, and also add the name to both service A and service B, so that basically they can be traced. So if we just here service B, if I do that, save that, and then if I go back, if I directly call this again, I have a Jaeger client already up. So it's if I do a find trace, so you can see here the trace is already spans created and etc. So give you the two spans, JAG service A and JAG service B. As you can see, is automatically these two spans build up as one trace. I think that's pretty much that's what the time for this talk, and also I have 4 to go through the MicroProfile APIs and specifications. I think we have 1 minute for questions. Are there any questions? Let me stop share my screen.
So I've been trying to answer some of them in the chat on YouTube. as we've been going through. Hopefully people have seen that. One person asked about whether, I think it was Carlos. Hi, Carlos. Does OpenLiberty provide instrumentation for OpenTelemetry? Emily's covered that. Yes, it does through MicroProfile telemetry. I provided a link to our blog in the chat on YouTube. Does OpenLiberty support virtual threads? Emily, did you want to comment on that at all?
That's a great idea. Great question. We are trying to experiment the virtual thread. So it's basically one thing to say is OpenLiberty is basically trying to keep up with Java SE as well. Once we have SE, we support all the LTS for Java, Java 17, and also we also look at the non-LTS as well, as Java 18, 19. We at the moment we just discussing how to utilize the virtual thread. As you know, Liberty has a great threading pool model. So, however, we want to see whether the virtual thread could provide even more great functionalities to make managing threads and also resources more efficiently.
Yep. I managed to locate an open PR that we have open, as Emily mentioned, on virtual threads. So I posted that. If you want to follow along with the PR, if you want to follow the progress we're making with virtual threads, then check it out. The great thing about open source is it's all in the open. So head over to GitHub and you can always follow along with our progress and where it's heading. There's been another question. Emily, you might want to take this. Can I use functional style reactive non-blocking in OpenLiberty?
Yeah, this is great. Yes, you can. Actually, we also have a blog on the, it's in the Jakarta RESTful Web Services. You have this kind of the non-blocking functionalities. And plus, there's a MicroProfile reactive messaging. I think Grace and I did a few talks with the MicroProfile reactive messaging together with OpenLiberty. Again, we have quite a few blogs. If you go to openliberty.io/guides and just type in reactive messaging, you can see quite a few guides to get you started.
Yeah, fantastic. Exactly. There's quite a few. There's some testing guides. There's some sort of just creating reactive microservices with MicroProfile reactive messaging, as Emily mentioned. So yes, absolutely. If you want to give it a go, you can yourself. I couldn't see any other questions in the chat that I hadn't answered with some links.
Yeah, only one presented by Pavel. He's asking about which maybe software architecture fits the best with this kind of application for cloud native.
Say that again. What's the best?
What's the best software architecture?
What's the best software architecture?
So that's like a million question. That's what you hire consultants for. Yeah, it's a tricky one.
Yeah, it's a great question. I think there's a kind of guidance, which is a 12-factor app. So basically, it's use that as a guidance to create your microservices. And one the factor which called externalize your configuration. You can easily use MicroProfile config to directly fulfill it. Also, I had YouTube videos about 12-factor app using MicroProfile. So yeah, search that.
No, that's great. Thank you, ladies.
Thank you, love.
Yeah, it was great. So thank you very much. Well, it was an exciting presentation, and I hope we can look forward to hearing from you in the future.
Absolutely, we'd always love to come back. Thanks for having us.
Yeah, thanks for having us. Great. Yeah.
Thank you, Emily. Thank you, Grace. It has been a pleasure to listen you in this talk. Your ability to communicate complex concepts in a clear way was impressive, and I am sure we all have a much deeper understanding of this topic. Thank you, guys. Okay.
Thank you so much, guys.
Maria, thank you, Victor.
All right.
Yeah.
Take care.
Take care. Bye.
Bye.
Okay. Cambiamos a español entonces.